Hello all, this is Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. We are in the chapter of continuity and in today's video let us discuss about the problems on discontinuity. So if a function is given, at what points the function is discontinuous. So we will discuss about this by taking as many examples as possible. Okay, so some of the questions are given on the board, we will discuss on it. So let us start. But if you are new to the channel, don't forget to subscribe the channel. Okay, let us continue. The first thing that we should remember is where do we generally find the points of discontinuity? That is the question, right? Remember this, a function is discontinuous at all points which are not in its domain. Okay, now, so first of all, take the function. Know what is its domain. Okay, now, in the remaining points, okay, now, which are not in the domain of the function is not continuous. I will give you an example. We know that domain of tan x is any real number except odd multiples of pi by 2. Domain of tan x, this is domain of tan x, correct or not? So which means that in the domain of tan x, we don't have odd multiples of pi by 2. X cannot be 1 pi by 2 or 3 pi by 2, 5 pi by 2, etc. So therefore we can say that tan x is discontinuous at those inputs where x is odd multiple of pi by 2. So what are they? Plus pi by 2 or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2, and so on. All these inputs are not in the domain of tan x. So at all these inputs, tan x is discontinuous. So this is the first thing that we should always search in a given question about discontinuity. So whenever they are asking at what points the function is discontinuous, first of all, know its domain. Know which points or which inputs are not accepted by the function. At those points the function is discontinuous. But that is not enough. Some functions are discontinuous even at the inputs which are in its domain. I'll give that example also. So before giving that example, what is the first point to remember? A function is discontinuous at all points which are not in its domain. Okay, now fine. Next. Before going to the example which I was trying to explain, complete this one also. Where is f of x is equal to root x discontinuous? Obviously the domain of the function is x greater than or equal to 0. So if I try to substitute a negative value in place of x now, f of x is not defined. So we can say that root x is not continuous at x less than 0 for all negative values of x. Okay, the function root x is not continuous. Okay, now there are functions which are discontinuous even at the points of its domain. Okay, I'll give that example now. Here is that example. If f of x is equal to step x, what is the domain of step x, the greatest integer function? The domain is any real number. Here x can be any real number. Does it mean that the function does not have the points of discontinuity? It's not like that. Even though the domain is any real number, this function has points of discontinuities. What are the points of discontinuities? The points of discontinuity. What are the points of discontinuity? Are x belongs to z. When input is an integer, for every integer, okay, na, the function is discontinuous. You can take any one integer. For example, let x is equal to 2. At x is equal to 2, let us check whether the function is continuous or not. First left hand limit, f of 2 minus, which is equal to step of 2 minus. And we all know that 2 minus means 1.99 something, and step of 1.99 something is 1. And what is its right hand limit? F of 2 plus. That means step of f of 2 plus means step of 2 plus. Step of 2 plus means 2.00 something. Correct or not? Step of 2 plus is 2. Observe that left hand limit is not equal to right hand limit. The function is not continuous. Correct or not? So I just gave you this example for you to understand that even at the points which are in the domain of the function, there is a possibility that the given function is discontinuous. Okay, now so when we take more and more examples, you will get a clarity how to find out the points of discontinuity. So for that, let us take as many examples as possible. And already I have discussed about the concept of discontinuity in the previous videos. Okay, you can take the playlist of continuity and check for the concept of discontinuity and types. Okay, in that I have given clear concept about the types of discontinuities, and in this video let us concentrate on solving the problems. Now let us start solving the questions. Let us try to find the points of discontinuity of various functions. Here is the first question. Find the set of points of discontinuity of the following functions and also mention the type of discontinuity. Okay, now, so whatever functions we are going to mention, we have to find the set of points of discontinuity, and at the same time we have to also say what type of discontinuity it is, whether it is removable type discontinuity or non-removable type. If it is removable type, is it missing point discontinuity or isolated point discontinuity? Or if it is non-removable type, is it finite type of discontinuity or infinite type of discontinuity or oscillatory type of discontinuity? So all this. Okay, now so let us see what is the first function. So the first function is f of x is equal to 1 divided by x square minus 5 into mod x plus 6. Dear students, this is a rational function. A rational function is continuous in its domain. Obviously, a rational function is continuous in its domain, which is where the numerator is a polynomial and denominator is a polynomial, but it is not continuous in its points which are not in domain. Okay, now first of all, what are the points not in domain? A rational function is not defined if the denominator is 0. Now, for what values of x the denominator is 0, you have to find. At those values of x, the function is not continuous. So once again, this is a rational function. The denominator should not be equal to 0. So find the values of x where the denominator is equal to 0. At those values of x, the function is not continuous. So let now take x square minus 5 mod x plus 6 equal to 0. We all know that x square and mod x square both are same. Now you all know how to factorize this, correct or not? So mod x square minus 3 into mod x minus 2 into mod x plus 6. I am not teaching you how to factorize. I hope you already know it. Okay. In the first two terms, let us take mod x common into mod x minus 3. And in the next two terms, let us take minus 2 common. Mod x minus into minus 2 into 3 is 6. Okay. So here and here we can take mod of x minus 3 common into mod x minus 2 equal to 0. So when the product of two unknowns is equal to 0, either the first one is 0 or the second one is 0. What if the first one is 0? So we will get mod x is equal to 3, which means x is equal to plus or minus 3. And similarly, if the second one is 0, then automatically what will you get? Mod x minus 2 is 0 means mod x is equal to 2 and x is equal to plus or minus 2. So dear students, from this we can say that if x is plus or minus 3 or plus or minus 2, then the value of the denominator becomes 0. So these four inputs are not in the domain of f of x. Okay, now so x is equal to, so what is the domain of this function? Any real number except these four values. So at x is equal to plus 3 minus 3 and plus 2 and minus 2, the function f of x is discontinuous. At the remaining inputs, obviously the function is continuous. At these inputs, the function is discontinuous. Now, okay, we have found the set of points of discontinuity. This is over. And what is remaining? And also mention the type of discontinuity. What type of discontinuity? I can say directly what type of discontinuity without doing anything. In these kind of cases, at the points, at these points, if the denominator is becoming 0, okay, na? If the denominator is becoming 0 and the numerator is not 0. See, numerator should not be 0 and the denominator should be 0, okay, na? If that is the case, or else where numerator is a finite number but not 0 and the denominator is 0. So in that case, what type of discontinuity will come means infinite type discontinuity. Infinite type discontinuity will come. So we will see many examples. In upcoming questions, we will see many examples where we get infinite type discontinuity. When does it come? Very clear. If the denominator is becoming 0 at these points and the numerator is non-zero finite number, then we get infinite type discontinuity. Okay, now just in this example, I'll prove that it is in infinite type discontinuity. just in this example. And in the upcoming examples, I'll say directly that it is infinite type discontinuity. Okay, now in this example, let me prove that at x is equal to any one number. For example, at x is equal to 3, I will prove that the function has infinite type discontinuity. Okay, for this, let us take LHL of the function at x is equal to 3. So at x is equal to 3, dear students, I'm finding LHL. LHL is limit x approaches 3 minus f of x. 1 divided by x square minus 5 mod x plus 6. Dear students, x is approaching 3 from the left side, which means x is just lesser than 3. But x is positive. When x is just less than 3, x is positive only. Na? Since x is positive, we will write mod x as x. Okay, now we can write mod x as x. So I can remove this modulus. After that, you know how to factorize the denominator. So the denominator, okay, limit x approaches 3 minus, the denominator is 1 divided by x minus 3 into x minus 2. Okay, fine. And x approaches 3 minus means what? X is equal to 3 minus h, where this h is approaching 0. Okay, I'll replace x with 3 minus h in this particular function, and I'll take h approaches 0. So which is equal to limit h approaches 0, 1 divided by, instead of x, I'll write 3 minus h. So 3 minus h minus 3 into 3 minus h minus 2. So therefore, limit h approaches 0, 1 divided by minus h into 1 minus h. Dear students, if h is approaching 0, even minus h is also approaching 0. Okay, na? So, and 1 minus h, if you substitute 1 minus h, you will get 1. This is one positive number, and minus h is a negative number, minus 0.000 and so on. The denominator is taking minus 0.00000 and so on. So 1 divided by minus 0.0000 and so on is what? Minus infinity. So the left hand limit is approaching minus infinity. And already we have discussed in the types of discontinuity that if LHL is taking minus infinity or plus infinity, or else if RHL is taking plus infinity or minus infinity, then what type of discontinuity do we get? We will get infinite type discontinuity. Therefore, f of x, this particular function f of x has infinite type discontinuity. In case if you do not know all these types of discontinuities, please do check the video of the types of discontinuity in the playlist of continuity. Okay, now so let us come back to this. At all these points, same, you can prove it yourself that at these points the function has infinite type discontinuity. Okay, so dear students, this function is discontinuous at these 4 points, and at each point we have infinite type discontinuity. Okay, let us go for the next function. Here is our second function, f of x is equal to 1 divided by, again a rational function, again the denominator is a quadratic polynomial. Just like the previous question, you can try it, but one thing you have to remember is that always we cannot factorize, correct or not? So x square plus x plus 1, we cannot factorize, we cannot split the middle term to factorize it. So what are we going to do? Let us use method of completing squares. Okay, now so what I'm going to do is I'll write x square plus, here I'll multiply with the numerator with 2 and denominator with 2. So 2 into x into 1 by 2. Okay, now so I just wrote x as 2x by 2. Okay, now and after that this denominator is in the form of a square plus 2ab. It is in the form of a square plus 2ab. If we also have plus b square, then this becomes a plus b whole square, correct or not? So it is in the form of a square plus 2ab. Let me add b square. So a means x, a square plus 2ab plus this is b, so plus b square. Since you have added 1 by 2 whole square, let us also subtract 1 by 2 whole square. So this becomes this becomes this, and we added and subtracted this, and we have not yet taken plus 1. Next, dear students, if you simplify the denominator, what happens? 1 divided by, this is a square plus 2ab plus b square, which is a plus b whole square, and then 1 minus 1 by 4 will be 3 by 4. Dear students, if you observe one thing, the denominator is something whole square plus 3 by 4. What is the meaning of it? x plus 1 by 2 whole square is always greater than or equal to 0. These are our basics. Square of any real number is always greater than 0 or equal to 0. We also have plus 3 by 4. And x plus 1 by 2 whole square plus 3 by 4 is always greater than or equal to 3 by 4. So which means that our denominator is always greater than 3 by 4 or equal to 3 by 4. What is the meaning of it? The denominator can never be equal to 0. Because the minimum value of the denominator is 3 by 4, how can it be 0? Please think about it once. Since the denominator cannot be 0, this particular function is continuous, where continuous for all x belongs to R. At all real numbers, this particular function is continuous. You substitute any value in place of x, the denominator cannot be 0. For that reason, this function is continuous. But is it necessary that I should do all this process? We can also use a discriminant, delta. Delta is what? B square minus 4ac. A is x square coefficient, B is x coefficient, and C is constant. A is 1, B is 1, and C is also 1. And if you substitute ABC values here, we get 1 square minus 4 into 1 into 1, which means minus 3. So if you have completed quadratic equations chapter, you will understand that since delta is less than 0, x square plus x plus 1 cannot be equal to 0. It does not have any real roots. X square plus x plus 1 is equal to 0 for no value of x, which means x square plus x plus 1 cannot be 0. That's it. We can decide like this directly by using discriminant. Okay, now or else you can do it like this. Okay, so I hope you understood why this function is continuous at all x belongs to R. Let us take another example. Here is our third function. Let us try to find the points of discontinuity if it exists. Okay, now observe the process. Some of us already know that this can be factorized and it can be written as x square plus x plus 1 into x square minus x plus 1. It's an important identity to remember. Okay, now x power 4 plus x square plus 1 is equal to product of these two polynomials. It's very important, and if you remember this identity, obviously if you remember this factorization, obviously it will be useful in many of the questions in algebra, in calculus, and in many of the chapters. So try to remember this directly. However, I will teach you how to factorize it. Okay, now anyhow, how to get this product, I am teaching it here. 1 divided by x power 4. What I am going to do is, I will write x square as 2x square minus x square. So 1x square is 2x square minus x square, and don't forget this one. So why did we do this? Because this is perfect square. It is x power 4 means what, dear students? X power 4 means x square whole square. So it is in the form of a square plus 2ab, b is 1 here, plus b square, 1 means 1 square, correct or not? It is in the form of a square plus 2ab plus b square. Therefore the denominator becomes x square plus 1 whole square and then minus x square. Next, let us use a square minus b square identity, and what do we get? So 1 divided by a square minus b square is a plus b into a minus b. See, I got the factorized product. This and this both are same itself. And dear students, already we discussed that this cannot be 0 for any value of x. Similarly, this also cannot be 0. You try to find the discriminant here. Okay, what is the function? I am rewriting it. 1 divided by x square plus, instead of writing 1 plus x, I will write x plus 1 into x square minus x plus 1. X square minus x plus 1. See, try to find the discriminant here, delta. You will get what? B square minus 4ac. You will get minus 3. Here also, if you try to find delta, what do we get? B square, that means minus 1 whole square, minus 4 into a into c. A into c is 1 into 1. Here also we got delta minus 3. Since delta is negative for these two polynomials, they cannot be equal to 0. This cannot be 0 and this also cannot be 0. So dear students, the denominator cannot be 0. This person is there in the denominator. It cannot be 0 for any value of x, because its factors are these two. This cannot be 0 for any value of x, and this also cannot be 0 for any value of x. So which means that denominator cannot be 0 for any value of x. For this reason, this function is also continuous for all. The symbol is what? For all x belongs to R. For all real numbers, this function is also continuous and it does not have any points of discontinuity. Okay, now let us continue with next question. You can try this question and you can find if there are any points of discontinuity. Just like the previous questions, you can try this. We'll go with the next function. Here, particularly, we have to be careful while finding the points of discontinuity. The first thing is the denominator cannot be 0, obviously, correct or not? So denominator should not be 0 because at those points the function is discontinuous. Okay, so for what values of x the denominator is 0? And here the base is e. Okay, for what values of x the denominator is 0, you find it. So log mod x with base e, if it is equal to 0, converting logarithmic function to exponential function, mod x is equal to e power 0, correct? So mod x equal to 1, which means if I remove modulus, I'll keep plus or minus here. So for these two values of x, the denominator becomes 0. So therefore, dear students, therefore x is equal to 1 comma minus 1 are what? Points of discontinuity. Points of discontinuity. And obviously at x is equal to plus 1 and minus 1, the denominator is becoming 0 and the numerator is a finite number. So can I say directly what type of discontinuity? Already I have discussed it in the first example. What type of discontinuity? We will have infinite type discontinuity. To prove that it is infinite type discontinuity, you can find LHL or RHL when x is approaching plus 1 or when x is approaching minus 1. You can try it and you can check whether you are getting infinite type discontinuity or not. Okay, now, but the problem is not over. Yes, of course, the function is discontinuous at the values of x when the denominator is 0, but it is what function? Logarithmic function. What is the domain of logarithmic function? That also we have to work out. Okay, now what is the domain of logarithmic function? Log of a function is there, right? Log of something, that something must be positive. Okay, now that means mod x must be positive. And remember, mod x is always positive and at the same time mod x can also be equal to 0. Correct or not? Dear students, x can be any real number. For all positive real numbers, mod x is positive number. For all negative real numbers, mod x is positive number. No problem. But remember, x cannot be equal to 0. X cannot be equal to 0 because log 0 is not defined. You can substitute any other number in place of x. Any other positive real number or negative real number we can substitute, not a problem. Because of modulus, even the negative inputs will become positive inputs. But the problem is that x should not be 0, because if x is 0, log 0 is not defined. So what is the third point of discontinuity? The third point of discontinuity is x is equal to 0. Therefore, x is equal to 0 is a point of discontinuity of this particular function. Now the question is, what type of discontinuity? Here you cannot say that it is a infinite type discontinuity, because when x is 0, the denominator is not becoming 0. The denominator is not defined. So here we are supposed to find what type of discontinuity is there. Okay, now, so already totally 3 points of discontinuity. Therefore the function is discontinuous at 1 comma minus 1 comma 0. This is over. Okay, now 3 points of discontinuity, that's it. For all the remaining values of x, the function is continuous. Only at x is equal to 1 comma minus 1 comma 0, the function is discontinuous. And I have already told that at these two inputs, the function is having what type of discontinuity? Infinite type of discontinuity. I did not complete the solution. We are supposed to find at x is equal to 0, what type of discontinuity are we getting. So let us do that. So dear students, at x is equal to 0, we are trying to find what type of discontinuity are we getting. First let me find left hand limit, LHL. Limit x approaches 0 minus 1 divided by log mod x. Okay now, so dear students, x approaches 0 minus means x is equal to 0 minus h, where h is approaching 0. So what happens to the question now? Limit x approaches 0 minus, we are not writing this, we'll write h approaches 0. Limit h approaches 0, 1 divided by log mod. Instead of x, we'll write minus h, log mod minus h. And dear students, limit h approaches 0, it is nothing but 1 divided by log of modulus of minus h is h itself. And remember, h is positive. Okay now, when h is approaching 0, log h is taking what value? Infinity. Log 0 is log of 0.0000 and so on. The denominator is approaching infinity, but it is 1 by infinity only na? And 1 by infinity is how much? 0. So left hand limit is 0. What about right hand limit? What about right hand limit? Similarly, you can find what is right hand limit. RHL, x approaches 0 plus. 0 plus means x is equal to 0 plus h. Okay na? And can you continue? Can you solve it yourself? If you solve it in right hand limit also, will get what answer? Even RHL also will be equal to 0. So left hand limit will be 0 and RHL will also be 0. You try to find out the value of RHL. You can do it yourself. But what about value of the function? F of 0 at x is equal to 0. What is value of the function? 1 by log 0. Log 0 is not defined. Don't say infinity. When x is exactly 0, logarithm will not accept that input. Log of 0 is not defined. What is the meaning of it? The function is not defined when x is 0. So f of 0 is not defined. Dear students, in types of discontinuity, already we have discussed that if LHL is equal to RHL, left hand limit also we got 0, right hand limit also we got 0. If LHL is equal to RHL, which means limiting value of the function exists, but the value of the function is not defined, then we can say that the function has missing point discontinuity. Therefore, what is this type of discontinuity here? The function has missing point discontinuity. In case if you are not knowing these types of discontinuities, do check the video of types of discontinuities in the playlist of continuity. Okay, so the function has missing point discontinuity at x is equal to 0. So therefore at x is equal to plus 1 and minus 1, it has infinite type discontinuity, and at x is equal to 0, it has missing type discontinuity. Okay now, so I'll give you a similar question and try it and let me know what answer you have got. What are the points of discontinuity and at what points and what type of discontinuity also. So here is the question, here is the function, same like the previous question. Instead of x, we have x square minus 1. Okay now, so remember that while finding the points of discontinuity, case 1 is where the denominator is 0. You will get some values of x. Okay now, case 2, x square minus 1 should not be 0. Okay, these are the two cases that we will take, and you will get the points of discontinuity, and you also find what type of discontinuity are you getting in those functions. Okay, so do it and let me know in the comment sections of what answer you have got. Okay, in case if any help is needed, I'll try to upload the same problem in the form of shorts. Okay, fine, let us go for the next function. Look at this function, dear students. F of x is equal to 1 divided by x minus step x. Okay, now let us try to find the points of discontinuity. Obviously, we all know that x minus step x is nothing but fractional part of x. I hope you all know what is a fractional part function. Let us come back to this. Fractional part. Okay, first thing is what? Case 1. Case 1, denominator should not be 0. Okay, now because if denominator is 0, the function is not defined. So let us try to find the values of x for which denominator is 0. Okay, so fractional part is 0. When fractional part is 0, for all integers, fractional part of any integer is 0 only, right? So what is the meaning of it, dear students? So for all x belongs to z, that means for all integers, the denominator is equal to 0. So therefore the function f of x is discontinuous, or for all x belongs to z. Okay now, for all x belongs to z, f of x is discontinuous. And obviously what type of discontinuity, dear students? When the denominator is becoming 0 and the numerator is a finite non-zero number, you are getting what type of discontinuity? You are getting infinite type discontinuity. Infinite type discontinuity, right? So at every integer this particular function is discontinuous. And what type of discontinuity? Infinite type discontinuity. So in case if you have any doubt, you can try to use LHL or RHL and you can see if you are getting plus infinity or minus infinity or not. Okay na? So it is only case 1. Do we have any case 2? There is no case 2 here, there is just this one, that's it. So denominator is 0 for all x belongs to z. Therefore at these points the function is discontinuous. And what type of discontinuity are we getting? Infinite type discontinuity. And there is one more possible question in this. Okay now, how many points of discontinuity are we getting? How many points of discontinuity? The function is discontinuous at all integers. For all integers the function is discontinuous. That means how many points of discontinuity? Number of points of discontinuity. The answer is what? Infinity. There are infinite points of discontinuity. Okay, now the number of points of discontinuity is infinity. At all integers it is discontinuous na. So therefore the number of points of discontinuity is infinity. No cases. This is the solution. Okay, we'll go with next question. Yes, dear students, it is sum of many functions. Correct or not? 4x is a polynomial. It is continuous. 7 into step x contains step x, and we all know and we have already discussed that greatest integer function is discontinuous at all integers. Since the second term contains step x and since this particular function is discontinuous at all integers, even f of x is also discontinuous at all integers. Keep this in mind. Okay na? So therefore the function f of x is discontinuous at all integers. Okay, next coming to this one. This particular function, what is the domain of log of 2 plus x? 2 plus x should be greater than 0, which means x should be greater than minus 2. If x is greater than minus 2, this function is defined. Therefore, when x is less than or equal to minus 2, this function is not defined. So all the values less than or equal to minus 2 are not in the domain of the third term. So at all these inputs, the third term is not defined. Therefore, even these inputs are points of discontinuity of f of x. So from the second term, we understood that at all integers f of x is discontinuous. And from this we have also understood that f of x is discontinuous. So therefore, dear students, what are the points of discontinuity? X belongs to all integers union minus infinity comma minus 2. So at all these points, here we have infinite points of discontinuity. Here also we have infinite points of discontinuity. Therefore the function is discontinuous at all these points. So that is about f of x. Okay, we will discuss more about these kind of functions which are under algebraic operations like addition, multiplication, etc. in upcoming videos. We will discuss more about these examples. For now, let us go for the next question. Here is one more function. Obviously, for what values of x the denominator is equal to 0, if you find it, you will get the answer. So take the denominator equal to 0. So we will get 1 equal to root 2 into sin x, which means that sin x is equal to 1 by root 2. And in trigonometric equations chapter, we have already learned how to find the different values of x. If sin x is equal to 1 by root 2, it is sin pi by 4, correct or not? Sin 45 degrees. Where pi by 4 is called its principal value. So in trigonometric equations, you should have already learned. So what is the general solution? Then x is equal to, for what values of x? Sin x is 1 by root 2. For all n pi plus minus 1 power n into alpha. For all these values of x, okay na, sin x is equal to 1 by root 2. So dear students, the denominator is equal to 0 for all values of x, where n is any integer. What is this? I hope you already know it. These are called general solutions, and this contains all the infinite values of x. How to get those infinite values of x? Since n is a integer, if you substitute n is 0, 0 plus 1 into pi by 4. You got the first point of discontinuity, which is pi by 4. If you take n is equal to 1, you will get pi minus 1 power 1 is minus 1. So pi minus pi by 4, which is 3 pi by 4, that is the second point of discontinuity. And if you take n is equal to minus 1, minus pi minus 1 power minus 1 is minus 1. Minus pi minus pi by 4 is minus 5 pi by 4. That is the third point of discontinuity. Like that you will get all the infinite points of discontinuity. So at all these inputs, the denominator is 0, the function is not defined. Therefore, these inputs are what, dear students? These are the points of discontinuity. And obviously, since the denominator is becoming 0 and the numerator is a finite number, all these points are what? At all these points, what type of discontinuity do we get? Infinite type discontinuity. Infinite type discontinuity. So these are the points where the function is discontinuous, and it is what type of discontinuity? Infinite type discontinuity. So this is only part 1 of the problems on discontinuities. In part 2, let us take as different models. Okay, now like if this is level 1 questions, those are level 2 questions, those kind of models which they will ask in mains and advanced. Obviously, let us discuss those problems in part 2. Okay, so that's it in today's video, dear students. I hope you have understood these examples. Okay, so in case if you understood these examples, don't forget to like the video, do share it to your friends, and see you all in next video. So in next video we'll discuss main problems on the concept of discontinuity. Okay, and after that particular video, so we will also start concepts on differentiability. So anyhow, so keep getting back to the channel. Obviously, I hope that I'm giving you a lot of input. I'm really these video. I really believe that these videos are very helpful for you. Okay, thank you, dear students. Thank you for your time. See you all in the next video. This is M. Sandeep Kumar. Take care.